we're going to take a look at how these angles will give us special ratio. So for lesson 2.1b, the second part of this lesson, we're going to look at some special cases for which you can actually come up with the ratio without using a calculator. Different from what we saw in the homework, instead of getting answer that is like 29.7 degree or 65.4 degree, there are times when you can actually get the answer without using a calculator. You can find the angle without using a calculator, or you can find the ratio, the sine ratio, cosine ratio, or the tangent ratio. You can actually find the value of these ratios without using a calculator. But what happened is, we are going to look at the first triangle first. And we will see how this triangle, 45, 45, 90, we're going to see how this triangle will give us exact ratio without using a calculator. So, looking at the first triangle, 45, 45, 90, here is a right triangle. What do you know about this right triangle? 90 degree. And what about the 45, 45? What does it really mean? What kind of triangle do we call it? If you have two angles equal, what is it? Isosceles. If these two lines have equal length, what would be the ratio between these two lines? 1 to 1. They have the same length. And that means if I already know the length of these two lines, I can now calculate the third side on this triangle using the Pythagorean theorem. A squared plus b squared equals c squared. And in this case, I have a equals 1, b equals 1, and c is your hypotenuse. 1 squared plus 1 squared give us c squared. And solving for this, we have square root of 2 for this line. And that means when we are working with a right triangle that involves 45, 45, 90, you can actually find the ratio without using a calculator. If I try to calculate the value of tangent 45 degree, using a tangent of 45 degree, I would expect to see the ratio between the opposite and the adjacent. If I'm to calculate tangent 45 degree using this angle here, the line opposite to it and the line adjacent to it will both give us 1 and 1, and my calculator will eventually give us, oops, something is wrong. What's wrong with my calculator? It is in radian. Make sure your calculator is in degree mode. If your calculator is in radian mode, everything will now be wrong. So here, let me try it again. Tangent 45 degree, and that will give us the ratio of 1, or 1 over 1. At the same time, let's say, if I want to find the ratio for sine 45 degree, using the same angle here again, the line opposite to it will still be 1, and the adjacent side would now be root 2. On my calculator, we will indeed end up with 1 over root 2. If you enter sine 45 degree, you will end up getting the same value as what we got here. But of course, my graphing calculator cannot give me exact values. It will only run everything to decimal value. If you try it out with 1 over root 2, it will indeed give us the same answer. So what happened with these special right triangles is that we can actually come up with exact values without dealing with these runoff error. When you are using your calculator, you get runoff error because your calculator cannot come up with exact values. Your calculator will always run your answer to 10 decimal places. But now, once you understand the ratio for these special angles, we can now calculate all these without using decimal value. So that's the ratio between a 45, 45, 90, between the sides on this 45, 45, 90 triangles. Moving on to the next one. I have a right triangle with 30 degree. If you try it out on your calculator, sine 30 degree will give us 0.5. That's one of the ratio that your calculator can come up with a nice number. If you expect 0.5 from sine 30 degree, what would you get for your opposite and for your hypotenuse? What kind of fractions would you expect to see for 0.5? Can you turn 0.5 into fractions? 1 over 2, yes. When you are working with a right triangle that comes with a 30 degree, you would expect to see the ratio between the opposite and the hypotenuse with a ratio of 1 to 2. Or in another word, your hypotenuse will always be twice as long as the opposite side. Once you have the two lines here, we can now calculate the third side using the Pythagorean theorem. If I call this adjacent side A, then A squared plus B squared equals C squared. Solving for A, 4 minus 1 equals 3. The adjacent side would now be square root of 3. And this would be the ratio between these three lines on a right triangle, a 30, 60, 90 triangle. Using this right triangle, if I'm to rotate my triangle to have the 30 degree up here, the line opposite to it will still be a 1. This is the line opposite to this angle. Here is your angle. And your hypotenuse will still be the longest side on your triangle. They will still give us a ratio of 1 to 2, with the third side being root 3. And this time I can consider this right triangle as having a 60 degree instead. So these are the three special triangles that you will be using to solve your right triangle without using a calculator. On your chapter test, you're going to see the long calculator part with a lot of questions similar to these. Okay, these are the ones that you cannot use a calculator to solve, well, that you will expect to not use 1 when it comes to special right triangles.